12,000 years ago, at the edge of a melting world, a small child was laid to rest deep beneath an Alaskan hearth. The burial should have been just another piece of the first American puzzle, except her DNA didn't match any living group. Instead, it unlocked the existence of a lost people, revealing that America's first settlers were already split into distinct lineages, hidden in plain sight. What did these ancient families know that we're only discovering now? The answer begins with what the archaeologists found in the pit. A tangle of roots and wind-blown silt covered the ground where Dr. Ben Potter's team began their work along the upper Tanana River. The spot looked ordinary. No mounds, no markers, just a patch of loess capping an ancient sand dune. Trowels moved slowly, layer by layer, as the team recorded every shift in color and texture. Decades of seasonal wind had buried the camp in a thick, fine dust, preserving the past under a blanket of sediment. In 2010, as the team traced the outline of an old hearth, they found what looked like burned animal bone. Sieving the dark, ashy fill, they realized the fragments were human. The remains belonged to a 3-year-old child, cremated inside the hearth itself. That alone was unexpected. No other known site in the North American Arctic had yielded a cremation from this era. The team documented every detail, bagging each fragment and noting its precise position. The context was fragile and irreplaceable. 3 years later, in 2013, the dig returned to the same shelter. Beneath the hearth's floor, the trowel caught on something delicate. Tiny, chalk-white bones appeared, undisturbed for over 11,000 years. The shape of the pit was invisible from above, and only the careful removal of each loess layer revealed the burial below. As soon as the team recognized human remains, excavation stopped. Potter contacted tribal representatives from the local Tanana Athabascan councils. No further digging happened until all parties agreed on the next steps. The process was slow by design, every movement watched, every decision discussed. With tribal consent, work resumed under close observation. The infant's bones were fragile, some no bigger than a fingernail. Archaeologists used brushes and bamboo picks, recording the depth and angle of each find. The grave goods, including antler rods, stone points, and an obsidian flake, were mapped and lifted only after full documentation. Each item was sampled for residue and mineral traces. The soil itself was bagged for later analysis, in case microscopic remains or pollen might tell more of the story. To anchor the timeline, charcoal from the hearth and bone collagen from the burials were sent for radiocarbon dating at independent labs. The results converged. All 3 children had been buried around 11,500 years before present, near the close of the last ice age. The stratigraphy was clear. Distinct, undisturbed layers of loess separated the hearth from the burial pit beneath. There was no sign of later disturbance. The context held, and with it, the promise of answers locked in ancient bone and earth. Throughout the process, the team's field notebooks filled with sketches, measurements, and observations. Every action was double-checked, every sample cross-referenced. The protocols were strict because the stakes were high. A single misstep could erase the evidence of a vanished world. What lay beneath the hearth was not just a burial, but a record of care, intention, and the oldest childhood graves ever found in the North American Arctic. A shallow depression beneath the ancient hearth held more than bone. Arranged in the soil were objects that once belonged to hunters. 2 stone projectile points, 4 carved antler rods, a single flake of obsidian, and a dusting of red ochre. Each item had been placed with care beside the infants, not tossed or scattered, but set as if in ceremony. The projectile points, finely shaped and still sharp, were the kind used to bring down caribou or bison on the tundra. The antler rods, incised with tiny cross-hatch marks, may have served as foreshafts for spears or darts. Their surfaces showed wear from use, suggesting these were not made for the grave, but came from the daily life of the camp. The obsidian flake stood out. Its glassy black surface came from a distant place, hundreds of kilometers to the east at Hoodoo Mountain in what is now the Yukon. No local rock matched its chemistry. This single piece traced a line across the Ice Age landscape, hinting at connections that stretched far beyond the Tanana River Valley. Even in a world of small bands and constant movement, people found ways to share or trade precious materials over immense distances. Red ochre, ground to a fine powder, coated the bones and artifacts. The color bled into the soil, marking the burial with a vivid, iron-rich stain. Across the ancient world, ochre was used in rituals of death and renewal, sometimes to symbolize blood, sometimes the earth itself, sometimes both. Here, the ochre covered not only the children, but also the tools, binding them together in a single act of farewell. The pigment was not a local afterthought. Its deliberate application speaks to beliefs that reached beyond the visible world. Nothing about this burial was accidental. The youngest members of the group were honored with the tools of adult life, hunting gear, pigment, objects of value. To give up these items meant giving up a measure of security in a harsh land. Yet the sacrifice was made and the grave sealed. The arrangement of goods, the ochre, and the sheltering hearth above all point to a community that saw meaning in death and perhaps hoped for something beyond it. These choices reveal a spiritual investment in the lives of children, even those who never grew old enough to hunt or speak. In the cold, uncertain world of terminal Pleistocene Alaska, the act of burial became an expression of memory, hope, and the bonds that held a people together. Wind swept through a landscape that looked nothing like modern Alaska. 11,500 years ago, the Tanana River Valley was part of Beringia, a world of open woodlands, grasslands, and winding streams. The ice sheets had pulled back, but the land was still raw, shaped by meltwater and scattered with ancient spruce. In this shifting environment, families built their camps along riverbanks, following the rhythms of the seasons and the migrations of animals. Their survival depended on flexibility. At Upward Sun River, the remains of hearths and food refuse reveal a community skilled in both hunting and fishing. Bones of bison, wapiti, and small mammals littered the site, but among them, archaeologists found something new for this age: the unmistakable vertebrae of salmon. Analysis confirmed these were Pacific salmon, caught and eaten at a time when most of North America's earliest peoples were still thought to rely almost entirely on big game. This is the earliest known evidence of salmon use in the Americas, and it marks a turning point in human adaptation to the far north. The annual return of salmon gave these families a dependable food source during late summer. Fish could be smoked, dried, and stored, carrying them through leaner months when herds were scarce or scattered. But they did not abandon hunting. The stone points and antler rods found nearby were used to bring down caribou and bison, animals whose bones, hides, and sinew shaped every part of daily life. From the evidence left behind, it is clear that people here tracked herds across open steppe, set up temporary camps, and worked together to butcher and process their kills. The camp itself was more than just a scatter of tools and bones. Hearths provided warmth and a place to cook, but also acted as the center of family activity. Around these fires, people mended clothing, shaped new weapons, and cared for children. The presence of infants and the remains of daily meals suggest a community that included all ages, a sign that this was not just a hunting outpost, but a seasonal home. Faunal remains show a broad diet: bison, wapiti, hare, ground squirrel, and salmon. The mix of species points to a strategy of taking what the land offered, from river to tundra. Seasonal clues like the presence of salmon bones and the age of animal remains hint at a late summer occupation, when resources were at their peak. The people of Upward Sun River moved with the seasons, but their ability to exploit both land and water set them apart from earlier, more specialized hunters. In this world, every successful hunt and every basket of fish helped knit the group together. The stability provided by a mixed subsistence base made it possible for families to survive, gather, and even honor their dead. The bones, tools, and hearths left behind are silent, but they speak of ingenuity, cooperation, and a deep knowledge of a land in constant change. A single obsidian flake, small enough to fit on a child's palm, draws a line through the ancient north. Its glossy black surface, sharp and volcanic, does not belong to the gravel beds of the Tanana River. Chemical sourcing traces its origin to Hoodoo Mountain, a volcano nearly 600 kilometers east in what is now the Yukon. That distance, across rivers, marshes, and shifting tundra, is not a trivial gap. For obsidian to reach Upward Sun River, it had to travel by hand, passed from one group to the next, each exchange linking families separated by weeks of walking. Archaeologists chart the movement of this stone across the Ice Age landscape, mapping possible corridors along the Yukon and Tanana rivers. These waterways, carved by meltwater and lined with spruce, offered natural highways for people and goods. Hunters and families traveled with the seasons, but the obsidian's presence proves they also carried stories, knowledge, and objects from far beyond their own camps. The flake itself is evidence of a network, one that stretched from the volcanic highlands of the Yukon to the heart of interior Alaska, long before the first written record or mapped boundary. Other finds from the site reinforce the pattern. The projectile points and antler rods, shaped with skill and worn by use, mirror tools found hundreds of kilometers away in both Alaska and eastern Siberia. These similarities suggest more than isolated invention. They point to contact, imitation, and perhaps even shared rituals among distant bands. Even as glaciers retreated and the land bridge of Beringia shrank beneath rising seas, people remained connected by the exchange of materials and ideas. Obsidian, in particular, was prized for its sharpness and beauty. It could be traded, gifted, or carried as a token of connection between groups. The journey of a single flake might span generations, each new owner shaping it for use or ceremony. In a world where resources were unpredictable and alliances mattered, such exchanges helped knit together a patchwork of small, mobile communities. They allowed families to move beyond the limits of their own foraging grounds, forging ties that could mean the difference between scarcity and survival. Yet the evidence from Upward Sun River also hints at the boundaries of these networks. While obsidian and ideas moved across hundreds of kilometers, genetic studies would later reveal that some groups remained isolated for millennia, developing unique lineages in the shelter of Beringia. The same rivers that brought goods and stories could also define the edges of social worlds. The obsidian flake, an object out of place, yet found at the heart of a child's grave, captures the tension between movement and separation, between the reach of human connection and the realities of a vast, frozen land. Inside a Copenhagen laboratory, a tooth from the Upward Sun River child arrives under heavy security. Ancient DNA work demands a level of caution that borders on obsession. One stray skin cell, one cough in the wrong room, and millennia-old secrets could be lost or rewritten. Professor Esker Villeslev's team puts on full-body suits and gloves, working in a clean room where even the air is filtered. The first step is to drill into the tooth's dense inner tissue, where DNA has the best chance of surviving the ages. The powder is divided, and multiple extractions run in parallel, each in a separate lab, to guard against contamination and lab error. Every result is cross-checked for chemical signatures of ancient DNA, damage patterns from time and burial, not the smooth, unbroken strands of modern contamination. The genome that emerges is astonishingly complete for its age. This is not a handful of genetic scraps, but a high-coverage sequence, allowing the team to test and retest every finding. Independent labs repeat the extraction and sequencing, confirming that the results are not a fluke. The child's mitochondrial DNA reveals something unexpected. Two infants from the same grave belong to entirely different maternal lineages, C1b and B2. Both found only in the Americas, but never before in the same Ice Age burial. These results pass every control, every check for modern DNA, every test for laboratory mix-up. The data are real. And already, before the family tree is drawn, the diversity inside this single grave hints at a deeper, more tangled story than anyone had imagined. As the genome sequence from the Upward Sun River child came into focus, researchers found themselves staring at a family tree unlike any drawn before. The DNA did not fit neatly with the ancestors of today's Native Americans. Instead, it revealed a branch that split off early, before the Great Migration south. This branch, now called Ancient Beringian, stands as the oldest known offshoot of the people who crossed from Asia into the Americas. Genetic models built from thousands of markers across the genome show the ancient Beringians diverged from the main ancestral group around 20,000 years ago. For thousands of years, they remained isolated in Beringia, separate from the ancestors of later Native Americans. The models, QP graph trees and admixture graphs place the ancient Beringians at the base of the Native American family tree, not as ancestors of any modern group, but as a sister lineage to both northern and southern Native Americans. The split is not a simple fork. After admixture with ancient North Eurasians and East Asians, the founding population in Beringia fractured. One side became the ancient Beringians, and the other side divided into two branches: northern Native Americans, whose descendants include the Athabascan and Algonquian speakers, and southern Native Americans, who peopled Central and South America. The ancient Beringians, meanwhile, remained in Alaska, their lineage frozen in time. Yet, as the Holocene dawned and the climate warmed, the ancient Beringians faded from the genetic record. No living population carries their genome in pure form. Their disappearance leaves a spectral imprint, a ghost lineage known only from the bones of a child buried beneath the Alaskan loess. Today, ancient DNA turns graves into new voices in the debate over who we are and where we come from. As more genomes surface, the boundaries of ancestry and belonging shift in real time. The first Americans were never a single story, and every discovery reminds us that identity, like history, is always unfinished.